Glacial striations, or glacial striae. Glacial striations, or glacial striae, are scratches or gouges carved into bedrock by glaciers. Glacial ice itself is not hard enough to scratch rock, but glaciers erode and entrain rock, and this rock trapped within glacial ice moves along the base of glaciers by ice flow. The moving rock provides the abrasive tool to scratch and gouge the underlying bedrock. Most striations occur as multiple straight or parallel grooves. Finer sand within the ice can even scour the bedrock, providing a polished look. Most glaciers visible today are those created during the last ice age, which peaked over 20,000 years ago, when a great ice sheet covered much of the northern United States and Canada. This massive ice sheet, now gone, had a profound effect on our landscape. Some of the best evidence for this ice sheet are glacial striations. Look for striations on bedrock surfaces, particularly in places where the rock has been protected from weathering and erosion. This includes places where the overlying soil and sediment has only recently been removed, and along the shores of the Great Lakes. To help visualize the flow of glacial ice, check out this video of the Mendenhall Glacier in Alaska, produced by the Extreme Ice Survey Project. The Mendenhall Glacier drains a large area and flows into the Pacific Ocean. The video here is a time-lapse video compiled from thousands of photographs. Glaciers flow much too slow to be readily observed. The fastest can only flow a few feet per day, and larger ice sheets flow much more slowly. The time-lapse photograph reveals the steady flow of glacial ice into the ocean. Also note that the ice is loaded with sediment. This rock is eroded up ice and is exposed as the glacial ice melts. It is this rock that scours the underlying bedrock. Like many glaciers around the world, the Mendenhall Glacier is slowly shrinking in size. Global warming is causing the ice to lose more ice in the summer than it's gaining snow in the winter. I created an animated figure that attempts to illustrate how striations are created. The figure consists of a glacier, shown in blue, and large rocks within the glacial ice. The glacier and rocks will move along the bedrock. Now the ice is flowing. The glacier is not changing in size because the amount of ice gained is equal to the amount of ice lost, but note that the ice is flowing is evident by the moving rocks. It is these moving rocks that will create striations. Now the glacier is shrinking. The amount of ice lost in the summer is greater than the amount of snow gained in the winter. Similar to how the Mendenhall Glacier was shrinking in the Extreme Ice Survey video. Even though the glacier is getting smaller, the glacier still flows from the center to the edge, and striations are still being created. Glacial striations don't simply provide evidence of past glaciers, they also reveal the direction of ice flow. Recognizing and mapping the existence of glacial striations was key to mapping the extent of the ice sheets during the last ice age. Shown here is a map by Thomas Chamberlain from 1882 depicting the limits of the former ice sheet and striation directions shown in orange. Note that along the edge of the former ice sheet, streams of ice called lobes flowed out of the central ice mass. Here's a more detailed map of striation directions for the Duluth area, authored by George Schwartz in 1949. In western Lake Superior, an ice stream flowed down the long axis of Lake Superior, as is evident by striation directions along the lakeshore that run parallel to the shoreline. Moving away from the lakeshore to higher elevations, striation directions change, pointing directly away from the lake. This provides evidence that the former ice stream flowed up and out of the Lake Superior Basin.